Communities and Ecosystems is the title of this chapter, and what it really means is that all the things that we've done in the past come together here. This whole course moves from small things to bigger and bigger and bigger things, and here's finally where we put it all together. This is the level at which you may see it in some of the films I've shown you. If you think about Life in the Undergrowth, this is all how you put it together. And if you're looking at Discovery Channel and Animal Planet, most of the time, yes, you're looking at certain organisms, but they're always part of a whole. And so this is how this particular chapter is set up. Now, I lead you into this by looking at humans and the environment, because in a way that sets the stage for some of the interactions. Always having to remember that humans are very much part of the equation, and in this scenario, what I'm doing is I'm bookending this chapter with aspects that involve humans. So the first part is to look at how humans impact biodiversity, and then towards the end, we're going to take a look at how humans impact the whole enchilada, if you will. Now, when you investigate biodiversity, which is of course what we'll do in the lab today, then one of the things you can do is define certain measures, and these measures are then something that you can use to compare different habitats. And so, for example, species diversity would be one. And species diversity can simply be a count. You count how many species are in a certain geographic area, perhaps in the mountains, and then you compare that with how many species you find in the desert. And then you can figure out if there's any overlap and so on, and it gives you an opportunity to make direct comparisons. You can also look at genetic diversity. Perhaps you're not interested in the diversity of species, but maybe you're looking at a single species, but you're trying to figure out how diverse that single species is. And as a consequence, you can do an assessment of how many alleles there are at different loci in a population. So that is a different level of diversity, but it is still a measure of biodiversity. And one of the reasons why this is important is because if you have a population with very reduced genetic diversity, it may impact the survival of that population. Because in very genetically constrained populations, you may find that one disease wipes out the whole population. And so that would be a potential threat. You can also look at ecological diversity in an area. So perhaps you're looking at an island, and that island may have a tropical rainforest, and it may have a volcano, and it may have beaches, and it has rivers, and it has all kinds of habitats. Therefore, the ecological diversity on that island may be fairly great. If you think of the Hawaiian Islands, for example, there is all that stuff that I just mentioned, and as a consequence, those islands have a relatively high ecological diversity, which then in turn may lead to a high species diversity, because there can be all this allopatric speciation going on. So those are three important measures for diversity. Now, one of the questions you may ask is, well, why do I care? Why is this actually important? And it turns out that habitats and the diversity in those habitats isn't something that's thrown together randomly. It is a situation that grows together. And as a consequence of having grown together, sometimes when you impact a small part of that habitat or a small portion of that diversity, then the whole thing falls apart. And I want you to think about this in terms of an analogy as riding in an airplane, and this is our planet, we're riding in that airplane, and on that airplane, of course, there are a whole bunch of things that hold the airplane together, and many of those you can see on the wings, they're rivets. Now, if you're sitting in the window seat and you look out and it's a beautiful view and suddenly, boing, one of those rivets pops, that would probably give you cause for concern, because the rivet just popped, right? I mean, that's a mechanical issue with that plane. There's damage now. But, of course, when a single rivet pops, an airplane isn't simply going to fall apart. So you're probably going to say, well, that's okay. I don't know much about airplanes, but I can be sure that if a single rivet pops, that's not a big deal, and the pilot would probably know about this. Well, pilots tend not to look at single rivets, but they may be getting signals when another rivet pops, and another, and another. And eventually, of course, you get to the rivet. That rivet, when it pops, then the wing falls apart. And then suddenly everybody notices, right? But by that point, it's too late. So we have to be careful how we handle our rivets. And I think you understand the analogy. There is no easy way to figure out which of the organisms in an environment is going to be the key organism, that key rivet. We just have to figure out what kinds of rivets there are. That's an assessment of biodiversity. And then maybe learn about them so that we understand how important they are in that environment. Now, when we look at declines in biodiversity, we find that in the history of humanity, we tend to have a lot to do with declines in biodiversity. No matter where you look, it turns out that before humans, there was biodiversity. Since we're around, we've discovered more biodiversity. In some ways, since we ever thought possible. There are millions of species now named. But we have also had an impact, a negative impact on that biodiversity. And as humans, we are really the only species that has that level of impact. And not only on single environments, but on all environments. And this is something that you can document very easily. Wherever humans go, they tend to have a negative impact on the environment. And so when we look at the causes, we will see that habitat destruction or fragmentation is a significant cause. The release of exotic species, overexploitation, and pollution. So those are four very important kinds of causes. They're not perhaps the only ones, but those are the major ones, and most of these, unfortunately, we have something to do with. Yes, habitat destruction can happen when a volcano erupts or when a landslide occurs, but those events tend to be relatively localized. Now, it's obviously a huge problem when you have meteorites slam into the planet, and that has also happened, and there was a serious decline in biodiversity then. Of course, that's a catastrophic event. Since we've had humans roaming the planet, we've not had that level of catastrophic events, but it turns out that the activity of humans may, in fact, cumulatively turn out to be a catastrophic event. And that's something we're still in the process of finding out. So let's look at these. Let's start with habitat destruction. Habitat destruction is a pretty straightforward issue. I mean, if you build a mall and put in a parking lot or whatever it is you do, you are going to destroy some of the habitat. In fact, when it comes with humans, one of the differences is in habitat destruction, we don't let habitats recover. If you have a volcanic eruption or a landslide, then subsequently the environment can take over again, recolonization happens, and as a consequence, that habitat will eventually become useful again. Now, if you consider a mall, a parking lot, a city, those habitats tend not to be recolonized. Once they're there, they're permanent. And because they're permanent, you end up not being able to recolonize them. So they're lost to the environment, therefore habitat destruction is a final issue there. It turns out when we do this, we also in some ways make the habitat uninhabitable to us. So cities is one level of habitat destruction, and of course if we have cities, then that makes them habitable for us. But there are a variety of things that we do in cities or to environments that render them uninhabitable for us as well. Things like open pit mining, for example. That's a pretty serious problem when it comes to the habitat. And so this is the issue. If we tackle the environment the way we have been, then we tend to create a permanent change, and our expansion tends to be of the kind that we rarely let anything go back to the way it was. So urban development and mining, deep shaft and open pit, clear-cut logging, those are the kind of things that we're dealing with. Plus, of course, agriculture itself, which is a great benefit to us and to some species, namely those agricultural ones that we use, still renders the habitat uninhabitable for a large number of organisms. Now, if you, let me give you an example. Most of you have heard of the island of Borneo, where the orangutans live and so on, and you probably will recognize it instantly as a great place with tropical rainforest and huge diversity and lots of interesting animals and so on. Now, when you take a plane across the northern part of Borneo, and it's a very short plane ride, only about 20 minutes, but at 30,000 feet, all the way where you can see, the only thing you see is palm oil plantations. Palm oil plantations. Those are oil palms and made for growing palm oil, of course. That's an agricultural resource. But there is not a shred of rainforest to see. Now, there are significant swaths of rainforest left in Borneo, but not right there along that area where agriculture has taken over. And, of course, as a consequence, that has pushed out a lot of the species that Borneo is famous for, and it's striking. Now, it's still green, and from the airplane it still looks pretty, and most people who fly over there don't even recognize what they're looking at. But when you're a biologist, it makes you pretty sad. And so this is just something I want to point out to you. Even though it looks green, it's not necessarily the same quality of green than what it used to be. So that's habitat destruction. Introducing species. This is almost entirely a human phenomenon. It is very rare that a species is transported from an area where it is native to an entirely different area on its own devices. There are certain events, maybe it rafts on a log across a long stretch of ocean, but that's not very likely. Most likely it is that something happens as human-introduced species. And so we call these introduced species because there's actually an activity, a human activity that underlies that. And then when you find a species in a habitat where it is not native, then you would call that an exotic species. There are lots of examples of this, and there are lots of causes for this. Some of these causes include having international shipping going on. This is literally a boat which is loaded up with a variety of things and then moves across the ocean. And it brings with it not only the people and the human cargo and the chattels that it's supposed to bring from one place to another, but it actually also brings with it sometimes rodents, sometimes other vermin, sometimes insects. There's all kinds of things that have come and gone across the Atlantic and Pacific Oceans. Perhaps seeds. Whatever it is, this can cause problems, including habitat destruction, where one type of organism takes over, the loss of biodiversity as a consequence of that, and certainly the interruption of food webs. I'm going to give you a couple of examples for this because I find them instructive. The first one of these is the brown tree snake. And these examples aren't necessarily things that I have that are in the textbook. The brown tree snake is something that is a very nice-looking snake. I'll show you a picture in a minute. It is in its native habitat, one of a variety of snakes, but it was imported to the island of Guam in transport planes. So this was an introduction that happened because of the activity during the Second World War. This was not something where somebody thought, oh, what a cute snake, let's take it to Guam. This was simply where the snake, some of these snakes ended up in the materials that were being transported from the Philippines to Guam. The Philippines was also an important staging ground for the U.S. forces at that time, and so history here plays a significant role. As a consequence of this brown tree snake arriving on Guam, Within a few short decades, it eliminated all songbirds from the island. So when you now go to Guam, which is a nice tropical island, you will hear no bird song. None. Zip. And that's very unusual. It's a quiet island. Because there are no songbirds, this has increased the number of certain invertebrates, in particular spiders. So if you don't like spiders, don't go to Guam because they're everywhere, all shapes and sizes. The birds are not there to take them down. As you increase the number of spiders, that is going to decrease the number of certain other insects because the spiders are going to feed on those insects. And you can see how everything is kind of interconnected and how that one significant disturbance shifts all kinds of things around. Well, since there are no birds, but the snake population is large and healthy, they have now started to target lizards. And there are a few native lizards on that small island in Guam, and those lizards are now being eliminated as well. Now, people have tried to eliminate the snake, but when it comes to birds and when it comes to lizards, well, people don't really care that much. But then they realize, oops, this snake is actually also mildly venomous, and it has increased the incidence of snake bite among the human population. It is very interesting to go to Guam, and people tend to have, like in Hawaii, open homes because they want to let the wind in. And frequently there are reports that when parents sleep with their children, the snake will seek out the warmth of people sleeping. And it'll actually saddle up right along you and sleep there with you and warm itself up. And then when you roll over, it'll bite you in the butt. And this is literally what has happened. Now, this is okay if you're an adult, but if you have low body mass and a large snake, that can be dangerous. And so it has happened that small children have been envenomated, and they pretty much need to have treatment with antivenom at that point, or they might die. So this can be very serious. And so that, of course, has made people very much conscious of this problem. In addition, because it seeks out warm places, it will try to get into power stations, which are nice and warm. And since snakes are long and thin, on the way to the warm place, they sometimes cross wires, and therefore you end up with power failures. And literally every day there are power failures on Guam caused by the snake. And a friend of mine has been there several times, tried to figure out how you could best eradicate that snake, but there really is no easy way to do it. So the snake population is very large. If you take a few snakes out, even if you put a bounty on them, you can't find them all because they're able to hide. And so this is a big problem in Guam. And here is that tree snake. It doesn't look particularly bad. It's a cat-eyed snake. That's what they call it because it has vertical pupils. And you'll find it in the trees most of the time. So that's the brown tree snake. Second problem is zebra mussels. Zebra mussels are a non-native species of mussel which grows quite fast. It's actually a relatively small type of mussel. It's not the kind that you might eat or anything like that. It's a very small mussel, but it can get into things. And one of the places where it got into was cargo ships. And as these cargo ships traverse the ocean, they tend to put some water into the bilge area so that they become more stable. If you think about this, of course, the hull of a vessel, of a boat, is filled with air because it needs to float, right? And then you load things on top of that, which makes the boat slightly top-heavy and therefore easy to capsize. Well, you don't want that. So what people do is they pump water in to the point where the boat is relatively stable but obviously doesn't sink. And then when they reach North America and the different canals that they need to get into to travel perhaps to Chicago or something like that, what they'll do is they'll pump out that water, because when you go through a canal, you need to be higher up off the bottom. Plus, you don't have the wave and wind action that you would on the open ocean, so you don't need to worry so much about capsizing. So as a consequence, this ballast water is simply pumped out, and innocently and unbeknownst to the people on the vessels, you may have pumped out a bunch of different organisms with that bilge water. Now, these zebra mussels have spread, and because they spread very quickly and grow relatively easily in many different places, they have caused a lot of problems for native species. They basically occupy the habitat. Now, if you look at this shopping basket here, you can see that any of these very small metal areas on the shopping basket are colonized by the zebra mussel. Now, that's not where you find lots of organisms like to live. Organisms tend to live on a natural substrate, but zebra mussels simply cover up everything and leave no space for anything else, so that's a problem. In addition, they move into drainage pipes. So when you have a drainage pipe that goes into a body of water in North America, you tend to have filtered it so that the water, the effluent, is clean, but it is generally a little bit warmer than what you find in the body of water. And that is very attractive to the larvae of these mussels, and they will move into the drainage pipes. And so as a consequence of this, anything that is letting water into the Great Lakes, for example, has had to establish a parallel system for its effluents. One of those parallel parts is going to be cleaned, while the other one is working, and it's going to get blocked up by these mussels sooner or later. When it's blocked, then you switch to the clean one, and you start cleaning the one that's now blocked while the mussels colonize the other one. And so on an annual basis, people will have to make these switches and clean things out, and of course that's expensive. And you have to be careful that you don't pollute things, even though you're getting rid of these zebra mussels. So these were very interesting things that people had to do. Now here is the current zebra mussel distribution. This is now about 10 years old. Fortunately, because of an awareness of this issue, the zebra mussel distribution has been slowed, so the expansion has been slowed, but it's still there. One of my colleagues did a PhD at the same time I did. He has been working on this problem for some years now, trying to figure out, is there any way that you can give something to these mussels, put something in the water, do something to them that will stop their growth, and it's just very difficult. Now, as you can see, in red, the zebra mussel occurrence is clearly associated with connected waterways. I don't know if you know this, but you can actually get into North America way up here at the St. Lawrence River, and that's where a lot of international shipping comes in. And then you can travel through the St. Lawrence Seaway all the way into the Great Lakes. And there are all kinds of canals that connect you all the way down into the Mississippi Delta. So you can literally, if you wanted to, you can get on a boat in Florida. You can ship along the side of the Atlantic here. In New York, you can go north. There's a canal there, and then you can go all the way through the Great Lakes. Through the Great Lakes to Chicago, and then into the Mississippi. So you can do this grand tour around the eastern United States, and you can always be in the water. Of course, a mussel like this is going to be able to make use of that, and as a consequence, you'll find them essentially anywhere you have a connected set of waterways. Now, the list is much longer than that. If you think about starlings that started out in Central Park and then swept across the country, if you think of grasses, seeds, all kinds of things have been imported. The big ones that we've heard of are the cane toads in Australia that basically eat anything that gets in their path. Mongooses have killed off almost all the snakes on Caribbean and Indian Ocean islands. Therefore, it makes lots of space for rats. If you're in agriculture and you suddenly have no snakes but lots of rats, that's a problem. What are you going to do then? Nile perch is a problem not only in Lake Victoria in Africa, but Nile perch is also something that we've now found in the Great Lakes. And there are people who empty out their aquaria, and a particularly nasty aquarium weed, which looks great in the aquarium, but not so much when it gets out, is spreading through the coasts of North America and the Mediterranean. Now, a lot of these things are being addressed, but it's not so easy to actually figure out what to do. Lastly, overexploitation. Well, obviously, what that means is that if you harvest too much, then you're not going to have any left. So overexploitation of any resource is a problem. When you think about that for a minute, we are working with agricultural products all the time. This is some of the stuff we eat. Now, if all of a sudden somebody were to use up an entire season's worth of agricultural product with none left over, then we would not be able to reseed for the next season, right? So clearly, intuitively, we understand that this is a problem. But yet, in many cases, the economic pressures on individuals or groups of individuals will make them overfish or overexploit in general and not really worry about what might happen next year. So sustainable sourcing of food is something that has become increasingly important, and whenever food prices go up, you are going to see that it's because of some level of overexploitation compounded by a poor growth season. And so this is something that most consumers are now demanding. I want to make sure that when I buy fish, it's from a sustainable source. Because if we don't have fish from a sustainable source, then eventually we won't have any more fish. And by the way, as the human population is increasing in numbers, the demand for a lot of these products is increasing as well. So more people are eating fish, but there are fewer resources for where you can actually catch the fish. So long term, that can obviously be a problem. As a consequence of overexploitation, we've seen this in the past, lots of species are in danger. If you think of tigers, whales, bison in North America, a key example, turtles. The reason why we don't have as many sea turtles as we used to is entirely because of overfishing and use in turtle soup. That literally was the prime reason. And turtles don't reproduce very often as it is. So sea turtles are endangered only because people started eating them. And we've pretty much put a stop to that, except for very few instances. And if somebody gets caught with turtle parts in most countries, that's a significant fine and a jail sentence. Almost anywhere you go, including places like China and Vietnam and so on, which might be consumers of these turtles, that's definitely what's happening. So ultimately, at some level or other, it's the human drive for consumption that causes the impacts on vertebrates. There is a significant problem with consumption in China. And this consumption has been compounded over the last decade, really, because China has become very prosperous. And there are a lot of people who have a lot of money in China. And I don't know if you've been following the news recently about rhino killings and poaching. And almost invariably, this is because of rhino horn powder that is sought as a component in traditional Chinese medicine. And it is just hair. It's the same stuff as your fingernails. It's the same stuff as your hair. If you look closely as a rhino hair, you can see the hair in the horn. It's just stuck together and strengthened by the keratin. So it's really a very strange thing that somebody would want to eat hair, but that's apparently what happens. All right, that's the end of the first part.